Our next presenter, speaking on enabling plastic circularity through enhanced quality, we have Dr. Bettina Siggelkow from Clariant Produkte.
Hello, my name is Bettina Siggelkow, and I'm very happy that I can present to you today's challenges for enabling plastic circularity through enhanced quality. Before I start, I would like to tell you a little bit about our company, Clariant. We're a specialty chemical company, and we're Swiss-based, but we're acting globally. So we have, for example, 118 production sites all over the world, with a number of employees above 17,000 and a turnover of approximately 4.4 billion Swiss francs in 2019. Our business is based on 3 areas. The first area is care chemicals. Here we're providing solutions, for example, in personal care, in home care, or industrial lubricants. Our second area is catalyst. Here we're offering catalyst which can be used in chemical and fuel industries. And our third area is natural resources. In this area, we're providing additives and processing aids for the oil and refinery industry. With functional minerals, we can improve, for example, the purification of oils. And then we also have a big additives department providing additives for plastics, for example, for the use in packaging, automotive, or E&E. In October 2019, we have initiated a circular plastics economy initiative. This initiative is called EcoCircle, and it is based on the cooperation and the leveraging all the capabilities of the different business areas serving to support to close the loop on plastics. The initiative is based on 4 pillars. The first pillar is customer collaboration. Here we're focusing on reaching out to beyond our normal one-on-one customer relationship, but really reaching out to other players along the value chain to discussing their needs, understanding our products on the principles of circularity and the behavior within that scheme. The second area is value chain co-creation. Here we are offering our well-developed tools on creating innovations in these multi-stakeholder projects. We also have created centers of excellence. In these centers, our experts are working on fields within a circular economy, concentrating and developing deeper knowledge within their area of expertise, but also these centers have a regular exchange on knowledge, but also on experience. And by this, we can connect the knowledge of the different areas. And last but not least, we have decided to highlight those products of our portfolio which show a real good benefit in a circular plastics economy by giving the product name a designator Circle. This is in addition to our well-known EcoChain label, which highlights those products who are excellence within the industry on sustainability. Now, within our EcoCircle initiative are the challenges which I would like to present to you today. The first problem statement which I would like to highlight is on labels. Labels used in packaging. They are often used for not only displaying information to the consumer, but also to differentiate the different brands from each other. When it comes to recycling, to mechanical recycling, those labels are often creating some quality issues of the resulting recyclate because they are not separated within the mechanical recycling process, but shredded together with the packaging itself. Due to the fact that the labels are of different quality as the packaging, then this creates a reduced quality of the resulting recyclates. Therefore, we're seeking technologies which are either an adhesive technology, which is on the one hand taking care that the label is very good attached to the packaging, but on the other hand can easily be removed when it comes to the recycling step. Or a technology which supports the removal of the label within the recycling step. So for example, during the sorting and preparation of the packaging or during the washing step. The technologies should have a technology readiness level of approximately 5, should already have proven with a product or a process that it works, that it already has a certain maturity, and then be jointly developed from that further on. The second problem statement I would like to show is within chemical recycling. One product of chemical recycling from plastic is a pyrolysis oil. This pyrolysis oil can be used then, for example, in a refinery process, or for example, to create new monomers, and by this closing the loop of plastic circularity. But often here, the challenge is that the pyrolysis oil does not have the required quality because it carries impurities like chloride or nitrogen or sulfur, which then hinders an easy usage in further processing steps. So we are seeking for technologies who are able to produce these kind of pyrolysis oils, who have already proven at pilot scale, for example, with a TRL level of 7 or higher, to produce these pyrolysis oil, and who have already a plan to set up a commercial plant with a yearly production capacity of minimum 10 KT per year. These pyrolysis oils we expect to have the impurities which are a challenge to be used then for further upgrading. And here we want, together with the technology provider, to upgrade these pyrolysis oil by removing the contaminations or by stabilization, for example, of the oil, to allow a transportation of the oil and the easy usage in a refinery process. This we want to do together with the technology provider. By this, then, we hope, together with your innovation and your solution, in a partnership to develop the process further and support the industry in closing the loop on plastics circularity. I'm really looking forward to see your ideas and to hear from you. And now remain with a thank you for listening to me.
Thank you very much, Bettina, for that presentation. And we'd like to say Guten Morgen to Bettina. who is coming into us live from Germany. And I understand it's like 6:45 in the morning over there. Thank you so much for making the effort to join us so early this morning, Dr. Bettina.
It's a pleasure for me. Thank you.
Thank you. So we've got some questions to ask you. The first question that we have is the plastic feedstock sorted and has a consistent composition?
Ideally, the plastic feedstock is not sorted, but we understand that there might be reasons for at least a certain type of sorting. Consistency, ideally also, as plastic feedstock does vary naturally, shouldn't be really given. So the more flexibility the process is allowing, the better, actually.
Okay. Question number 2. What are the impurities that needs to be removed?
The impurities are chlorine, sulfur, also some metals, and to a certain extent also oxygen and nitrogen.
Okay. Question 3. Does the upgrading process need to handle potential variations of impurities within the pyrolysis oil?
So for the upgrading process, we believe that there is a certain variety needed, but also we see that there are some, let's say, priorities. So if some of the impurities are reduced more than others, this is fine. But of course, then the more of a broad of a variety is removed, the easier is the solution at the end.
Okay, we've got a few more questions. Question number 4, removal of plastic packaging. Just to be clear, are you looking for 2 different technologies? One to remove plastic packaging from bottles, and the other one is to look for sustainable plastic adhesive materials? Or do you want a total solution that can perform both functions?
No, we are actually looking for 2 solutions or either one of them. So what we see is that there is the difficulty, the main part is that these labels from the packaging are very difficult to remove. So we believe that this can be done in 2 ways, either by using a special adhesive for the label, so that this can be easier removed than in the recycling process, or for let's say a variation within the process which allows them to remove the label. I don't expect that both solutions are there at one place, but rather that it is either the one or the other.
Okay, we've got 2 more questions, 1.5 minutes left to go. Chemicals recycling technology. Is Clariant interested in pyrolysis technologies or specifically pyrolysis oil purification technologies?
Specifically in pyrolysis oil purification.
Okay. And our final question for you, to wrap up our 1 minute of question left, what will be the type of collaboration model that we'll have with Clariant?
So the type will be that we will collaborate in discussing the problem, in providing, if possible, also some solutions from our side, so that we have a collaborative development. On the other hand, we can also offer some pilot trials depending on the solutions. And finally, it will be a commercial relationship then. So, yeah.
Thank you. Well said. Thank you so much,
Dr.
Bettina Siggelkow from Clariant Produkte. Thank you so much for being with us on our program and waking up so early to be with us today. Thank you.
Thank you.
We have come to the end of the second crowdsourcing session on sustainability. Thank you to our speakers and to all attending this webinar for your active participation today. If you have any more questions, please continue to share them with us through the Pigeonhole Q&A platform. The answers to your queries and more information about this call will be published on the SOIC website at sustainability.innovation-challenge.sg. Now, please note that the proposal submission deadline is on 19 February 2021. The QR code for a post-webinar survey on day 2 of Tech Innovation 2020 will be shown on the screen shortly. We look forward to receiving your feedback if this is the last session that you are attending today. So do stay tuned for the crowd pitching session on health and personal care at 2 p.m. Singapore time. And once again, thank you so much, Bettina. Have a great day.
Thank you.